Hi, everyone. Thanks for joining us. I'm Aaron Kobernick, a Ruckus Solution Specialist here at Bytespeed. Today, we're being joined by Terry Henry of Ruckus Networks, who will tell us about the new Ruckus Wi-Fi 7 access points. If you have any questions, please add them to the chat window. We'll discuss at the end. Here's Terry.
Yeah, good morning. Thanks. So today we're going to talk about, what's the hype about Wi-Fi 7. So we'll talk about why we need a new standard. Going to review the benefits of Wi-Fi 6E on the way by. Talk about the three main features of Wi-Fi 7. We'll talk about the standard and where we're at for the standard with the IEEE and the IETF, and then what you need to get ready for Wi-Fi 7 for your infrastructure. So let's get started. So why do we need a new generation of Wi-Fi? Great question. So, we're going through a transition, a digital learning transition for education, but for others, it's the number of devices that's joining your networks is growing massively. You probably remember when you had a couple of devices in your house that were Wi-Fi, and now you may have 30 or 40. So the number of devices that need to share that airtime is growing exponentially, but also the amount of bandwidth per device is increasing. So we get things like virtual reality and augmented reality headsets that not only consume a massive amount of data over the Wi-Fi, but that it has to be very, very low latency, right? If you're trying to do a real-time application with a VR headset, for example, and you turn your head, to look at the wall of a museum virtually, you better, you can't have latency. You can't have that, hopping across, right? Or you're, in a meeting and you turn to look at someone in your VR headset, it better be instantaneous as though you were in person. And so that's what, that growing amount of bandwidth, need for lower latency and growing number of devices is what's really driving the new standard. So let's see where we've come from and where we're going to. So we went from Wi-Fi 4, so 802.11a AB, 802.11g, 802.11n was Wi-Fi 4, so called high throughput. Then we get to 802.11ac or Wi-Fi 5. And that came in, kind of a phase 1 and phase 2. So it was a long-lived standard for sure. And it was very high throughput. So both of those were about speed primarily. Then we get to Wi-Fi 6 and 6E, and they were high efficiency. So at that point, it wasn't so much about speed, it was about getting more devices on to share that air and to use it more efficiently. So rather than kind of the free-for-all of Wi-Fi 4 and 5, Wi-Fi 6 added some structure to, who can talk and when they can talk kind of thing on the network. And then we get to Wi-Fi 7. So Wi-Fi 7, also known as 802.11be, is extremely high throughput. So it is about, getting that next 20 billion devices on the network, but it's about a massive increase in speed, which you're going to see, as well as a much lower latency and more efficiency of that airtime. So it's the best of all the worlds. So before we go on to Wi-Fi 7, I just want to talk about Wi-Fi 6E. So I'm sure you're all familiar with Wi-Fi 6. A few years ago, we got to Wi-Fi 6E. And so Wi-Fi 6E has only one benefit over Wi-Fi 6, and that is the 6 gigahertz spectrum. And so in the 6 gigahertz spectrum, there is many new available channels, right? So if you look at this graph in the bottom corner here, in 5 gigahertz, we had, in 160 megahertz channels, for example, we only had 2 available to us, and in a lot of cases, only 1. In 6 gigahertz, we added another 7 available. So it actually makes 160 megahertz channels possible and usable, in an enterprise or an education environment. In high density environments, so say 20 megahertz channels, imagine if you were installing a large convention center or stadium or something like that, where you may have 200 APs that can all see each other. Well, up until now, we've only had 25 available channels. So you have to do a lot of, turning the power down and maybe using, shaping to try to get that signal to not overlap as much. 6 gigahertz gives us another 59 channels, right? So at 20 megahertz, that is. So, we get 70 plus channels that we can use. That means 70 APs can be, simultaneously sharing that airwave without, channel overlap, co-channel interference. So that's what 6E gave us. And the number of 6 gigahertz devices out there is growing very rapidly. So this is actually a very usable piece and very welcome. So we got more bandwidth in 6 gigahertz than in all of 5 gigahertz and 2.4 gigahertz combined by a long shot. So it was a massive, massive increase in the amount of airspace. So let's talk about what we get from Wi-Fi 7. So first of all, speed, right? So we went from Wi-Fi 4, so Wi-Fi 4 max, so max speed with 2 spatial streams, which is your typical AP out there, could do about 300 megabits per second. And then, so best case scenario, max speed with the maximum of spatial streams and the max channel width, we could do 600 megabit. Then we went to Wi-Fi 5, so it was 11%, 11.5% increase in speed. So substantially faster, right? So with 2 spatial streams, max channel width, you could do 1.73 gig, max of about 7 gig. Now these are theoretical. You'll never hit that in real life, right? You'll hit about half of that, in a practical speed. We got to 6 and 6E. So again, we went from typical AP 1.73 to 2.5 gigs, or from just under 7 gigs to 9.6 gigs theoretical maximum. So that was a substantial increase in speed. But again, 6 and 6E were more about efficiency than speed increase. So then we get to Wi-Fi 7. This is where it gets awesome. So that typical AP goes to 5.8 gigabits per second. So more than twice as fast on a typical AP, but in theoretical maximum, you got a 46.4 gigabits per second, right? So that is, a 320 megahertz channel width and 16 spatial streams. So not truly practical for your typical client, but the standard is capable of doing that. So there's a massive speed increase that comes with Wi-Fi 7. So a few other things that happen. So as I mentioned, we get 320 megahertz channels for the first time, right? So up until now, the best case scenario was 160 megahertz channels. We go to 320 megahertz as a possible channel width. So first of all, we double the speed there because we can use much wider channels. We also get 16 spatial streams. So instead of 4, 8 spatial streams, we go to 16. So imagine your channel width as the number of lanes on the highway, and then spatial streams is the amount of streams both in and out of that AP from the clients, and that can be shared across multiple clients. And then the last thing we get is 4K QAM. So we were 1024 or 1K QAM before, we get a 4K QAM. So that equates to about a 20% increase. So all things being equal, if you use the same channel width and the same number of spatial streams from Wi-Fi 6 to Wi-Fi 7, you're going to get a 20% increase in speed right there. So what does that do for us? Increased transmission rates, of course, lower latency, more spatial streams, wider channels, and improves the bandwidth usage. So, enhances your overall user experience, enhances or enables AR and VR, in the classroom and everywhere, as well as things like 8K video screens and things like that. And it speeds access to online resources. So our second major enhancement is something called punctured transmission. So in the past, You may want to run 40 megahertz, 80 megahertz, 160 megahertz channels, but there's often interference. So there's a rogue AP, or there's some kind of interference sitting in the middle of that channel. So up until Wi-Fi 7, we had to either move the whole channel and waste all of that channel bandwidth, or we had to use smaller channels. So instead of using an 80 megahertz channel, we would only be able to use a 40 and get half the speed out of that channel. So in Wi-Fi 7, we get something called punctured transmission, and we can actually puncture around interference in a channel. So rather than having to move the whole channel and waste all that spectrum, we can actually puncture around that and utilize that spectrum where we could not in the past. So what does that do for us? Well, it slices out channel frequencies that suffer from interference, and it keeps the channel in use, as I said. So it reduces the interference effects, it increases the link robustness, it lowers latency in noisy environments, right? So it improves that channel availability, maintains network service levels in dense or denser client environments, and it enables things like IoT applications where they may be sitting on small pieces of your bandwidth, right? So they may be sitting on a 20 megahertz channel and causing interference, and that would be a problem in the past, and it's not so much anymore. So the third major enhancement, and this is something called multi-link operation. So how multi-link operation works is it's pretty cool. So your client device, it has a 2.4 gigahertz radio, it has a 5 gigahertz radio, it may have a 6 gigahertz radio, but in the past you could only use one of those to talk to the AP, right? So you were limited by that bandwidth. In multi-link operation, it lets you use more than one radio, right? So you can use, the 2.4 and the 5 together, or the 5 and the 6 together for a couple of things. One is you can use link redundancy. So in link redundancy, you may send the same data down multiple radios. So if you drop packets on one of the radios, or get interference on one of the radios, you have a duplicate or a clone packet on another radio, so you just substitute that in and carry on. So latency reduction right there. Or you can use link aggregation, so you could aggregate that bandwidth together. So you aggregate your 5 gigahertz and 6 gigahertz radios together, for example, to substantially increase the amount of data from client to AP and vice versa. Or lastly, link selection. So you can do, say, like quality of service, and you can say, send my high priority video and voice traffic over the 6 gigahertz radio, and then my best effort, email and Facebook and whatever other junk over, the 5 gigahertz radio. So you can choose and get reduce your latency that way, right? And get better quality of service across wireless. So that's a big one. So one client device can talk to an AP over multiple radios, as I said, and different bands. So it provides link redundancy, it increases your throughput, it reduces your latency, and then improves network availability. Again, enables real-time applications and more bandwidth and faster access. So lots of things come with that multi-link operation, but it's something that was definitely not available in the past, and will truly increase reduce our latency and increase our throughput per client. So this is not a major feature of Wi-Fi 7, but one of the things that has just happened, a week ago, 2 weeks ago, is that there is something called automated frequency coordination. And so when you run 6 gigahertz channels, there's a couple of different modes in a 6 gigahertz channel. So you can either run in standard mode or low power indoor mode. And then there's a very low power mode, which is just inside a car or something like that. So that's got nothing to do with access points and us as, from a Wi-Fi perspective. But up until now in Wi-Fi 6E and Wi-Fi 7, you've only been able to run something called low indoor power mode. So essentially, it means you have to turn the radios down on all of your 6 gigahertz APs in order to not interfere with the incumbents, right? So the incumbent service providers and other companies have paid a lot of money for spectrum in the 6 gigahertz wavelength, right? They own that 6 gigahertz spectrum, and no one else is allowed to use it. And so, what they've decided to do is this automated frequency coordination. It's an FCC thing. And so essentially, in order to run standard mode, or in order to run any Wi-Fi 6E or Wi-Fi 7 access point outdoors, then you need to run AFC. And so essentially the access point sends its GPS coordinates to an AFC database, right? So it'll send that to the database, and then the database will say, these are the incumbents in your geographical location, and it will tell you what channels you're allowed to use in that geography and what the bandwidth is. And so that's all automated, right? So that's all between the AP and the AFC database and the FCC. However, up until now, we could not run 6 gigahertz outdoors. And to run it indoor, you had to run in low power mode, which means you turn those radios down. So 6 gigahertz is already a smaller footprint, right? So it doesn't cover as much geographical area as 5 gigahertz, or certainly less than 2.4. And so when you turn those radios down even more, you had to install more APs. So now that we have standard mode, now that we have automated frequency coordination that has launched and is now working, finally we can install outdoor APs, and we can turn our indoor APs to standard mode and run them properly. So again, the signal is still slightly smaller than 5 gigahertz, but it's substantially better than running in low power mode. So I just thought that was interesting that's just happened. So that is a year and a half late, I believe. So the FCC was supposed to have approved that long ago. But here we are, and it's finally up and running. So an interesting fact about 6E and 7. So let's talk about market growth for Wi-Fi 6E and Wi-Fi 7. So where's the market going with this? So this is an independent research. This is 650 Group. And essentially, what you can see here is that blue line is Wi-Fi 6E, right? So it was really only designed to be a stepping stone to get to Wi-Fi 7. And as you can see, it's a very short timeline for 6E, right? So it was essentially just to have exactly the same features as Wi-Fi 6, but to test the 6 gigahertz spectrum in addition to the features of 6. So Wi-Fi 7 is the main ongoing standard. And we have been shipping Wi-Fi 7 since December of last year. We'll fill in the rest of our portfolio over this year and early next year, but it is really the standard going forward. So Wi-Fi 6 is not going anywhere for a long time. It's got a very long runway, and Wi-Fi 7 is kind of the other side to that. So client availability, where are we with Wi-Fi 7? So as with any new standard, the retail APs launch first, right? So not picking on them, but that means D-Link, Linksys, the retail APs you'd see in a Walmart or a Costco or whatever the case. And they launch first because honestly, they don't necessarily need to comply to all the enterprise features. They just need to get basic compliance to the new standard, and then they start shipping. So a lot of them started shipping in 23, late 23. We got a few mobile phones early Q1 in 23. So Samsung, a few others. Apple is always, of course, substantially delayed, right? And then there was some high-end laptops, Dell's, HP's, kind of Q4 of 23 that support Wi-Fi 7. Then the first enterprise AP launch, so Ruckus was the first to ship Wi-Fi 7 in the end of last year. Since then, there's been a few announcements from other, top-tier enterprise vendors. but it's been slow coming. So we are shipping. We're shipping in quantity. It's actually real. I have one sitting beside me. And then, we'll start to see more and more enterprise vendors kind of pick it up later this year. And I would say, this year's iPhone, so whenever that is, September, will probably support Wi-Fi 7. But of course, Apple plays it pretty close to the vest usually. So where are we with the standard? So the standard itself, the IEEE target for Wi-Fi 7, last time I looked, it was May of this year was what they were targeting. That may slip. However, we've done final draft. We've been through plug fests, right? So a plug fest is basically when all the vendors that currently have an implementation come together and they do interoperability testing. So we've been through 8 plug fests, I believe 7, excuse me. We were the only enterprise vendor that participated in those plug fests. And then the Wi-Fi Alliance started their certification process in January. So that is already happening, Wi-Fi 7 certification. An interesting fact is that, so every device that gets Wi-Fi 7 certified has to get certified by the Wi-Fi Alliance, and we are the gold standard. So our Ruckus R770 is the gold standard by which all other devices are judged, right? So any kind of client device, any other AP, anything that is Wi-Fi 7 certified will get certified against the Ruckus AP. So if you're buying Ruckus, you can pretty much guarantee that your device is going to be interoperable with our APs. So what do you need to do to get your infrastructure ready for Wi-Fi 7, right? So there's a few things here. One is, it's about speed, right? So the first thing is, if you want to get the benefits out of Wi-Fi 7, you're going to have to run 2.5 gigabit Ethernet or 5 gigabit Ethernet, or in the case of our R770, it is a 10 gigabit Ethernet port. So if you want the true benefits and the throughput that you're going to be able to gain through Wi-Fi 7, first thing is you might want to look at your cabling, right? So if you're still running Cat5 cable, you're probably going to want to look at Cat6A, right, to get to 2.5, 5, 10 gig Ethernet. Next thing, you're going to look at your switch ports. If you're still running 1 gig switches, you may want to plan for a next generation switch upgrade, right, to 2.5, 5, or preferably 10 gigabit copper. Also power, right? So 3 radios, more spatial streams, wider channels, it all requires more power. So, 802.3 BT PoE power may be required, right? So if you still have switches that are 15.4 watts of PoE, you're going to have to think that through. If you don't have enough power, you may reduce features on the AP, or you may not be able to run those APs at all without upgrading. And then lastly, not really something you need to plan for from a hardware perspective, but in order to run 6 gigahertz, you have to run WPA3. So the vast majority of customers out there run WPA2 right now. You're going to have to get to WPA3. It's a required standard for 6 gigahertz and Wi-Fi 7. So, there is a transition mode, right? So if your clients are WPA2 or WPA3, or WPA2, they can join a transition mode SSID, and if they're WPA3, they'll upgrade to WPA3. If not, they'll stay on WPA2. But a 6 gigahertz radio has to be on WPA3. You have no choice about it. So just something to look out for. Not necessarily the end of the world. The vast majority of, pretty much all current clients will support WPA3. So not really an issue. There's some legacy devices out there, IoT devices, things that don't support WPA3 that could be an issue. To solve it, really, you just create another SSID that's WPA2 and then one that's WPA3 or WPA3 transition and deal with it that way. But it's just something to look out for. And then lastly, from a Ruckus perspective, Wi-Fi 7 is just the tip of the iceberg of the things that we can do, right? So yes, we have a full range of APs. We also have a full line of switches. So all the things we talked about, 2.5 gig, 5 gig, 10 gig, high power PoE, we have all those. We have Ruckus One, which is our cloud solution, which it sort of combines all the pieces. So it combines not just controller and switch management, but also analytics or AI platform. It'll combine CloudPath. It will combine later on. It's going to combine, the IoT server and things like that into a single cohesive package. So, kind of a one controller to manage them all, right? We have our CloudPath onboarding solution, very, very popular with education. So, how do you get your devices securely on the network, whether that be wireless or wired? We can do things like certificate management and install the certificate on your client devices. So, there's no passwords to lock out or lose or share. There's no WPA pre-shared key that people can share, or we all know that pre-shared keys are pretty much impossible to change once you've added them, right? You need to collect up all the devices and get everyone to change their pre-shared key. Well, we can do things like dynamic pre-shared key, which means it is a pre-shared key, but every user has their own pre-shared key that belongs only to them. And we can map that to their own VLAN on the back end. We can map that to a policy on the back end. And if that user leaves or loses their device or whatever the case, we revoke their pre-shared key and off they go. So very, very easy to change those keys, easy to delete those keys. And really, I mean, it makes it very difficult you can't lock it out. It frees up your help desk from extraneous client and user issues. And then, we have a very extensive AI analytics platform. So, things like being able to troubleshoot down to an individual client, and not just real-time troubleshooting that client, but somebody calls your help desk and says, hey, I couldn't get my iPad on the network 3 weeks ago. What was the problem? Well, right now, without analytics, you're going to have a hard time figuring that out, right? Or if you have really problems that only occur sometimes, right? We all have those, right? Intermittent issues. It would be a real stroke of luck if you happen to see it happen. But analytics is always watching. So you can go back in time in analytics and see exactly what happened. Did they not have enough signal strength? Did they have the wrong passphrase? Was the DHCP server scope full? Were they not getting DNS? So you can go back and troubleshoot all of those things and really, free up the help desk, solve problems faster and increase, your client satisfaction exponentially with data that's always being collected in the background. And analytics will make suggestions. So it says, hey, it can do, for example, channel planning and wireless is a problem, right? I mean, you've only got so many available channels, and so automatic channel change algorithms are good, but they don't have a view of the whole world, right? So analytics can see all of your APs and across your entire, building or campus or environment, and it can make suggestions to build a perfect channel plan. And not just a perfect channel plan, but if necessary, it can also reduce the channel width or increase the channel width, or it can reduce the transmit power, increase the transmit power to build a perfect RF environment. So something that was nearly impossible to do manually is now something that the algorithm runs every 24 hours and makes that decision whether it finds a better channel plan, did new rogues come in? And so, it can try to build as perfect as an RF environment as you possibly can. So, definitely some add-on pieces that will not just help you from a time and troubleshooting perspective, but it will make your users more satisfied, which is really the goal of anyone. So those are all some of the pieces. There's many other pieces available from Ruckus, but those are just kind of some highlights of major pieces. So that's all I have. Is there any questions in the queue?
No, I don't see any questions yet. I guess if anybody has any questions, feel free to enter them in, or you can email them to me as well. I can help get those answered. Um, so thanks for all that information, Terry. That was great. It's nice to learn all that new stuff about Wi-Fi 7. As for next steps, here's how you can reach us at Bytespeed. There's a few ways. One, you can call us at 877-553-0777, or you can email us at sales@bytespeed.com. Or you can visit our website. We have bytespeed.com/ruckus. There you can request a proof of concept. We can set up an online demo, or we can schedule a review of your existing infrastructure, help make suggestions, on how to meet some of these new standards. Again, I don't see any questions yet. So right now, Terry, unless you have anything else, I think we're good.
Nope. Just thanks for joining.
Yep. Thanks again, everybody, for joining us. I'll post, I guess we'll post this video to our YouTube channel, and then I'll be sending out links to everyone, once it's ready. So thanks again.
Thanks all.